Good day guys, welcome back to Wiki Science YouTube channel. In this video we'll be talking about a whole lot of things, but we'll be very concise about our topics, which we talk about the neurons, the ganglions, the classification of neurons, which include the myelinated, the non-myelinated. We have the somatic, we have the visceral, we have the cranial, we have the spinal, we have the sensory, we have the motor. There's also what referred to as intermediate. When we get to that aspect, we'll expatiate more. We have the adrenergic, we have the cholinergic, and we have type A, type B, and type C nerves or nerve cells. So now let's get started. What is a nerve cell? A nerve cell can also be referred to as a neuron, and it is the structural and the functional unit of the nervous system. When you talk about the nervous system, we talk about the central nervous system and the peripheral nervous system. Now let's look at the classification of nervous system. Nervous system basically can be classified into two. We have what we refer to as the central nervous system, and we have what we refer to as the peripheral nervous system. The central nervous system, as we all know, include the brain and the spinal cord. It includes the brain and the spinal cord. While the peripheral nervous system include the nerves around the body. All the nerves around the body, that is where we have the peripheral nervous system. And what make up the peripheral nervous system? That is where you have something like what? You have something like the autonomic nervous system, and we have what referred to as the somatic nervous system. The autonomic nervous system is divided into two. We have what referred to as the sympathetic nervous system, and we have what referred to as the parasympathetic nervous system. We have the sympathetic nervous system and the parasympathetic nervous system. Now when you talk about the brain is made up of what we refer to as two, or let's say we have three parts in general. What are those three parts? We have what we refer to as the forebrain, the midbrain, and the hindbrain. But for clear understanding, we're going to classify the brain into two. And one of those things we're going to classify brain into, we have what we refer to as into two. Instead of saying forebrain, midbrain, and hindbrain, we definitely say we have what we refer to as the cerebrum, and we have referred to as the brain stem. We call it the brain stem. Now when you talk about the cerebrum is made up of what we refer to as the cerebral hemispheres. We have referred to as the cerebral hemispheres. And we have referred to as the diencephalon. We have referred to as the diencephalon. But when you talk about the brainstem is made up of three parts. We have what referred to as the midbrain. We have referred to as the pons, and we have referred to as the medulla. Now, something important that which you must note here is that the midbrain, from the pons, we have an extra eminence, like we have an extra bulging from the pons. And what's that extra bulging called? It is called cerebellum. So from the development, we always have the cerebellum to develop from the same unit as the pons. So therefore, we can consider it as a bud of the brainstem. So when you're talking about the bud of the brainstem, we are referring to the cerebellum. On the other hand, we can say that the cerebellum belongs to one of the components of the brainstem. Okay, we have what referred to as the autonomic nervous system, which is divided into sympathetic and the parasympathetic. Okay, let's see. Here you should also have in mind that when you're not talking about the spinal cord, your spinal cord is made up of the spinal nerves. It's made up of the nerves and the ganglions. And that's the reason why we have to focus on neurons, which we refer to as nerve cells, and we have what we refer to as what? The ganglion. Now we have what we refer to as somatic. Somatic means they innervate what we refer to as structural components like the muscles. So that's why we call them somatic nervous system. Okay, they are coordinated by voluntary action. So that's why I refer to them as the somatic nervous system. However, the diencephalon here is divided into three. We have what referred to as the epithalamus. We have what referred to as epithalamus. We have what referred to as the thalamus. And we have what referred to as the hypothalamus. We get to see this in another video, which will explain completely the diencephalon and the overview of the central nervous system. We will actually get that in a separate video. Okay, I also want you to know that the autonomic nervous system is made up of nerve cells and ganglions. It's also made up of nerve cells and ganglion. What are these ganglion called? The ganglion from the autonomic nervous system, they are called autonomic ganglia. So these ones, they will provide us with, the autonomic nervous system will provide us with the autonomic ganglia. Yet we are yet to know what ganglion is. Why the central nervous system, specifically the brain is going to provide us with what we refer to as the cranial ganglion. We have the cranial ganglion. Why the spinal cord? The spinal cord will also present us ganglion. What is the ganglion called? We call it the spinal ganglion. So meaning that we have three different ganglion in the body: the cranial ganglia, the spinal ganglia, and the autonomic ganglia. The cranial ganglia develops from the what? From the brain. Spinal ganglia develops from the spinal cord, while the autonomic ganglia develops from the autonomic nervous system. Okay, let's come back to what we have as nervous system. Neurons. Let's come back to what we have as neurons. What's a neuron? As defined earlier, we said neuron is the word, is a structural and a functional unit of what? Of the nervous system. So here, the function of neurons is to relay impulses. They actually receive impulses, they conduct impulses, they generate impulses, they integrate impulses, and what they transmit impulses. That's the function of what neurons within what? Within the body. It is said to be a wiring or a network that connects the body through a relay of electrochemical impulses called action potential to different regions of the body to integrate one action or the other. So now, let's look at the structure of a neuron. A neuron is actually made up of, typically, we have what referred to as the cell body, we have what referred to as the axon, we have referred to as axon, and we have referred to as the dendrite. Now, when you hear the word cell body is a unit where the host function of the nerve or neuron is actually being integrated. So here we have so many constituents that make up the cell body, which will not go into detail in this aspect. We just want to see pick each aspect and their function. Also, the axon extends from the cell body and it carries impulses away from the cell body. It carries impulses away from the cell body. So that is what we refer to as the axon. But when you talk about dendrites actually, they are short extension of the cell body that carries impulses towards the cell body. So these particular short extensions that carries impulses towards the cell body are referred to as the what? The dendrites. Now, there are other structures that which you have in the neurons, like the telodendria, and you have referred to as the terminal bodies. You have the telodendria, and we have referred to as the terminal bodies. these make up a typical neuron. Now, there's something you need to know, that when we mention nerve fiber is actually related with the axons. So when I say nerve fiber, when I mention nerve fiber, I'm typically referring to the axon that extends from the cell body of a neuron. Now, the aggregation of nerve fiber carries impulses away from the wall, away from the cell body, and they can form several structures. The first one is a cylindrical structure called a fascicular. They can form a structure like this. This structure is called lemniscus. We are talking about the axons. They are whitish in nature. So they can form the lemniscus, they can form the fasciculus, and they can form something we refer to as the internal arcuate fibers, and many more. But once we talk about nerve fiber, let your mind stick to axon. Now, when you now talk about cell body, where cell body actually aggregates within the body, within the nervous system, is called nucleus. So when I have aggregation of cell body within the brain, I will call it nucleus or nuclei. And we have several nuclei that which you have here. We have the trigeminal nuclei and lots more like that. So the aggregation of cell body will form a what? A nucleus in the central nervous system. The aggregation of these particular cell bodies outside the brain, outside the spinal cord, we don't call it nucleus. What do we call it? Ganglion. So what's the ganglion? A ganglion is an association or aggregation of cell body outside the what? Nervous system, outside the central nervous system. So with the form referred to as the ganglion. This leads to what we refer to as the types of nerve cells. What are the types of nerve cells? We have what we refer to as, the first one is called unipolar neuron. We have what we refer to as bipolar neuron, and we have what we refer to as multipolar neuron. What is a unipolar neuron? A unipolar neuron is a nerve cell that which the axon and the dendrite emerge from one particular pole of the cell body. This is the cell body, and you can see that this particular cell body extends upward and also extends downward, but it's coming from just this region. So we call this unipolar what? Neuron. But in the case whereby the cell body projects out two different poles, so in which one forms the what? The dendrite, and the other forms the what? The axon. We call this particular neuron bipolar. But when you have a particular nerve cell in which one pole of the cell body forms the axon, and other poles or several poles from the cell body forms the what? The dendrite. We call this multipolar. We call it a multipolar. Now let's try to understand what we have explained so far here. We said in a nutshell we have three types of what? Of nerve cell. We have the unipolar, we have the bipolar, and we have the multipolar. The unipolar emerge from what? The axon and the dendrite emerge from one pole. In bipolar, the axon and dendrite emerge from what? Two poles. And in a multipolar, the axon emit from one pole, while the dendrites emit from what? Several poles. You can see they emerging from several poles. Okay, now let's come to the aspect of the classification of nerve cells. We classify nerve cells into myelinated and what? Non-myelinated nerve cells. What do we mean by myelinated? Myelinated means that there are supporting cells in which we always have nerve cells. The supporting cells in which nerve cells are found is called glial cells. These glial cells, they are also called neuroglia. They are also called neuroglia. Now, example of this is what we refer to as the Schwann cell. Schwann cell is an example of neuroglia cell. Other examples, we have so many examples like the oligodendroglial cell. We have referred to as the microglia cell. We have so many cells which they are supporting cells. They provide nutrition and they actually enhance the fast transmission of impulses. So now we have the Schwann cells. Okay, we have myelinated. So these nerve fibers now, they do not have what referred to as Schwann cells. But assuming I have something like this here, these are fats which they are formed from fat anyways, and this particular portion that I've actually made out here, we can refer to it as what? The Schwann cells. If these Schwann cells actually forms what referred to as what? The form referred to as the glial cells here, then this makes it a myelinated. But if it is non-myelinated, then it means that it does not contain the what? The neuroglia cells, like the Schwann cells. Because these glial cells, they form what referred to as myelin sheets. So if myelin sheet is not present, and myelin sheet is made from fats, so if it's not present, we call it what? Non-myelinated. Okay, we also have what referred to as the somatic and the visceral. What is the meaning of somatic? Remember, in this classification, we have what referred to as the somatic nervous system. And I said somatic nervous system is related to what? The coordination related to what? Consciousness, a voluntary action. Like actions related to what? Muscles. So here now, we refer to them as what? The somatic what? Somatic nerve cells. So the somatic nerve cells innervate specifically what? The muscles. They relay what? The voluntary actions. And when I say muscles, we mean skeletal muscles. Now, something you have to know here is that the muscle and the nerve fiber will be called. So this is the skeletal muscle, and we have the nerve cell, or let me say the nerve fiber. Let's just say nerve fiber. These two, they will be typically called what? They will be typically called the motor. They will be typically called motor unit. So this is a motor unit. We also have what referred to as sensory. We also have what referred to as cranial and spinal nerve cells. What are cranial nerve cells? Cranial nerve cells, they develop from the what? The brain. When we talk about cranial nerve cells, they develop from the brain. But when we talk about spinal nerve cells or spinal nerve fibers, they develop from the spinal cord. We're going to look deeply into spinal nerves now. We see how spinal nerves are formed. We also have the sensory and motor. When I say sensory, they transmit impulses. These nerve cells, the aggregation of these nerve cells transmit impulses towards the brain or spinal cord. Classification based on function. Classification based on function provide us with, we have what referred to as sensory, we have motor, and we have sometimes we have what referred to as intermediate. Okay, when you hear the word sensory, it means that they are actually connected to sense organs. They are actually connected to sense organ to receive impulse from the sense organs and transmit it towards the brain. That's why they are called sensory nerve cells. And what are the sense organs? You have the skin, you have the eye, you have the ear, you have the nose, you have the tongue. So all of these, they consist of sensory nerves. Okay, they consist of sensory nerves. Okay, we also, as a result of that, it is also called, because they are relating those, they are relaying these impulses towards the brain. We call them afferent nerve fibers. Okay, we also have referred to as motor. Motor means that they are associated with what? The voluntary actions like the somatic cells. So in this case, we also call this, it means that they are giving response. Because these nerve fibers, they take impulses away from the brain and spinal cord and direct it towards the what? Towards the effectors. And what are the effectors? Effectors are, when you hear the word effectors, effectors consist of, we have muscles, we have glands. So here we have, they are also called efferent nerve cells. Now when you hear the word intermediate means that they are actually found in between. So they are found between the afferent and efferent. That's why they are called what? Intermediate neurons. Okay, we also have referred to as the adrenergic and the cholinergic neurons or nerve fibers. When you hear the word adrenergic, it means that the neurotransmitter that which is produced by this nerve cell is either an adrenaline or it is what? Acetylcholine. It is either adrenaline or acetylcholine. So if it is adrenaline, it is called adrenergic, and if it is acetylcholine, it is called cholinergic. Okay. We also have referred to as type A, type B, and type C nerve cells. When you hear the word type A, these ones are classified based on the rate of conduction of impulses, or velocity of conduction of impulses. So here you have type A, type B, type C. Type A is also consists of type A alpha, beta, gamma, and we have delta. So this type A is very thick and is having a large diameter. So it can actually conduct impulses faster. So that's why I call it type A. While type B is having lesser diameter, lesser thickness, and it conducts impulses moderately. But when you talk about type C is having least diameter, is having the least thickness, and is having the potential to conduct impulses very slowly. Okay,